Question 6 builds on question 2. This one has got multiple unknowns, and so it's unavoidable that we're going to end up with different letters. There's going to be inevitably two ways to solve this, either with guess and check or with simultaneous. I'll try to show both. But the first thing to do is to fill in the table as best we can. So we can do as much as we can. 3 times 2 would make 6, so we'll put that in. We've got nothing in the next row, so we'll leave that for a minute. 5 times 6 is 30. 7 times 4 is 28. And so now we better start filling in some of the other bits and pieces that we can. Okay, so what I might do here is I might allocate an x. And I know that 4 times x is 4x. Now, I can't use x again, so this time I'll use a y. 6 times y makes 6y. If we do it like we did it in question 1, what we'll end up with is something we probably can't solve, because we'll end up with a bit of a messy looking total for each. And I think we can work out what the totals are, because up here they've given us the mean, and they've also given us one sneaky little relative frequency, which is quite useful. Now, that means that 4 over whatever this number here is, let's call it S for example, is going to be 20%. Now, I know that 2 over 10 is going to be 20%. So instead of looking at this as 2 over 10, if I think of a equivalent fraction by doubling both, I'd get what the low score is. If that didn't make any sense to you whatsoever, the other way to work this out would be to use algebra. Call it S, and over here on a side note, we'll say we know that 4 divided by S is going to be 20%, 0.2. Okay. So if we switch these two with transposition, then we'd have 4 over 0.2 be S, and so S is 20. So again, we found that this one here is now 20. Now, if we try and find out the total for the fx column, we can use the mean to do that. Because remember, again, if I call this one t, for example, if we take that over to the side here, I might do this one in orange, okay, just so that we've got something different here to work with. We know that the mean is the fx total divided by the frequency total. So that means that 5.5 is going to be t divided by 20. And if we times both sides by 20, then t will be 110. So we know that this one is 110. And suddenly this is starting to look a little bit more manageable. We can also sort of be a bit sneaky here and just fill out a little bit more of our percentage relative frequencies, if you like, because we know that if 4 over here is 20%, half of 4 is 2, so this one's got to be 10%, and then 6 is 3 bigger than 2, so that means that this one has to be 30%. Now, let's see if we can sort out these tables. Whether you're going to use guess and check or simultaneous equations, you are going to need to create some formulas. So let's look at what this column looks like algebraically. 2 plus x plus 6 plus y plus 4 equals 20. Collect up your like terms. So we've got 2 and 6 and 4 makes 12. Still got an x, still got a y. Bit of balance method or transposition. We'll take 12 from both sides. X plus y makes 8. Right. Just move that over a bit. So we don't get confused or use a new colour. Now I'm looking at this column here. I have got 6 plus 4x plus 30 plus 6y plus 28 equaling 110. Okay, I'm going to collect up my like terms. That means that if I've got 6, I'll drop in these x's first because that's easier. Right, 6 plus 30 plus 28 makes 64. That equals 110. Right, shift those 64s over, and now I'm left with 4x plus 6y equals 46. And here is my two equations. I've got equation number 1 here and equation number 2 here. Now, to guess and check this, what I would do is I would be having a look at focusing on this equation here. We've got two numbers added together to give me 8. There's not very many combinations that will work. I've got 1 plus 7, I've got 7 plus 1, I've got 2 plus 6, I've got 6 plus 2, I've got 3 plus 5, 5 plus 3, or 4 plus 4. And I am going to just start putting them into my calculator until I get the right combination. So if I start at the beginning with 1 plus 7, then I've got 1 plus 7 gives me 8. That worked. Let's test that it's going to work on the other equation. 4 times 1 makes 4. 6 times 7 makes 42. That does equal 46. So by pure chance, I managed to get the combination right the first time round. So I know that x is 1 and y is 7. If that doesn't work first time round, because that was just very lucky that it did, then I'll just switch it round and test 7 plus 1 and check that 4 times 7 plus 6 times 1 equals 46, which it doesn't, so no, that's the wrong combination. Once you've got a value for x and y, don't forget to go back up to your table and finish filling it out. The alternative way of doing this is to use simultaneous equations. And by using simultaneous equations, if they're not whole numbers, it'll always work for you. It's just an alternative way of doing it. The two equations need to match. If you're going to use the elimination method, at the moment I've got 1x and I've got 4x's in the second equation. So what I'm going to do is I'm going to multiply this entire equation by 4, which is going to change it into 4x plus 4y equals 32. I'm going to call this equation 1 and I'm going to call this equation 2. And I'm going to write the instruction that I want to do equation 2 minus 1. So if I go and stick equation 1 underneath here, and I subtract them, then 4x minus 4x gives me nothing. 6y minus 4y leaves me 2y. 46 minus 32 leaves me with 14. Now all I do is divide both sides by 2. And I find that y is 7. To find out what x is,
Could Emily Gamers and Julia
all I need to do is sub y equals 7 is sub y equals 7 into equation 1. And if I just go back to the really original equation 1, it's way easier. It would become, instead of it being x plus y equals 7, now that equals 8, now that I know that y is 7, it's just x plus 7 equals 8. 7 from both sides, and x is 1. So you can use either method, okay, and you'll get the right answer. Once you've done that, we need to go back to our table and we need to replace the values. So we know that here x is actually 1. We know that 4 times 1 is 4. We know here that y is actually 7. We know that 6 times 7 is 42. And now if we go hunting for these values here, I know that half of 2 was 10%. That means that 1's going to be 5%. And if 6 is 30% and 1 is 5%, then 7% is going to be 30 plus 5, which is 35%. You can double check to make sure all of that adds up to give you 100, and the question's completed.